Hey folks, welcome to an episode of Sound Decisions here on Passion for Sound. And today it's an interview with Rob Woodland from Curious Cables. I've previously reviewed Rob's Curious Evolved USB cable and I really liked it. It's become my standard go-to cable in my system. And so when I was hunting for somebody to talk to about USB cable design and why some of us hear differences between cables, despite the fact that there is some objective evidence that would suggest that we shouldn't hear differences between cables, I thought Rob would be a great person to talk to because he's gone through the journey of actually building his own cable from scratch, trying all different materials to see what actually made a difference, and also what he liked the most. This was done using a Zoom call, so as usual, video quality is going to drop off a little bit, but audio quality is still quite strong. I've done very little editing to this. I've just chopped out the ums and the ahs and the pauses so that the video is not too long, but beyond that, you're hearing everything that Rob had to say. So let's get into the USB cable conversation with Rob Woodland. Rob, welcome. Thank you for joining me today. We'll give a quick introduction by way of a question to you, I guess, to introduce yourself. Now, I'll explain why I've invited you on the channel and I'll hand over to you. So I've been really keen to explore for some time how USB cables influence sound. I know some people are very uncomfortable with that topic, but it's something I've felt perceptually and subjectively I've noticed differences. And so I've been looking around for someone that can come on and just talk about it with me, talk about what may or may not be happening. And of course you jumped to mind because I'm a huge fan of the Curious Evolved USB cable. It's my kind of go-to reference cable on my Hugo TT2 and M scaler setup. And so I thought we might start off if you could introduce yourself and give us a quick rundown of how you got started building USB cables and playing around with the different designs that could make a difference and how Curious Cables came to be. So over to you, Rob. How did it all begin and where's it come from?
It probably began quite a while back because in primary school I was put in charge of the PA system. So everybody on the quadrangle each morning, God Save the Queen, I was the guy operating the turntable. So, you know, an interest in music and audio happened from there. And I've been in retail. I've been in wholesale side of audio. I organised hi-fi shows for many years in Brisbane. So really, I'm just a DIY audio guy, have been for many years. You know, back in the late 90s, I got involved with Keith Eichmann with the bullet plug and his, you know, ideas of audio, and I licensed that technology and took it to the world, so to speak. And really, I've been playing around for many years. So when I came to set up a computer audio system, I could never get it to sound right. You know, I changed power supplies, different USB cards, footers, everything. And the only thing left really was the cable. And everybody told me that, you know, noughts and ones, it doesn't really make any difference. But really, you've got to go back to the SPDIF cable, where SP-DIF cables have been used for years. You know, everyone had a transport and a DAC, and we used it with a coaxial SPDIF cable. They all made a huge difference. Everybody used different cables. It was a huge industry. And suddenly, here we are, USB cables, everyone's saying, well, they shouldn't make a difference. But we've been through that whole process with SP-DIF cables, and we realize they do make a difference. Why they make a difference is the question. Look, some years back, I was on a little roundtable discussion with some other cable makers on a Positive Feedback magazine, and everybody had different ideas. It was interesting. But look, the conclusion was that the digital signal is sent as electrical impulses. So really, you've got to look at it, electrical impulses. It's very much an analog situation. So regardless of whether you think it's all ones and zeros and it doesn't make a difference, they're still affected by capacitance, by inductance, by resistance. All those things that happen to an analog cable will happen to a USB cable. So really, that's how it started.
And I guess carrying on from that, reading up on the website way back when I did the Curious Evolved review, my understanding is you went through lots of iterations and trying different types of metals and thicknesses and probably geometric configurations of the different conductors within the wire. Was it a subjective process, an objective process, a bit of both? What goes into, before we even get into the sound characteristics, for you, what went into designing the Curious cables?
It's really a mixture of science and art, and I'm sure that every designer will, say the same thing. So you've got to look at science, skin effect, dielectric constant, all that sort of thing's got to come into play. But at the same time, it's art, and it's working out what type of sound you want. So the first thing I did is I invested in a number of other USB cables, high-end USB cables, to have a listen to what they've done. And to give you an example, I got hold of a cable that was the fastest rate of, had the fastest rate of data of any USB cable. I plugged that in and listened to it, and really it didn't sound that great. It was quite flat and lacking dimension. And I thought, maybe this data speed isn't all that it's cracked up to be. Then I listened to some other cables that, said pure 90 ohm impedance. This is fantastic. This is where it's at. And I listened to that cable and didn't particularly like it. And then other cables, you've got to realize there's two schools of thought here. A lot of cables have this wall of sound. They present a lot of information in a big wall of sound, and a lot of people like that. And it's no problem at all. It's what they prefer subjectively. But when I listen to that, I prefer just pulling things apart and having space and dimension. And that's where the art comes in, because really I'm developing a cable that I particularly like, and a type of sound that I like. This dimensional, holographic, open sound is what I like. And I think that takes you closer to reality. So I'm trying to get closer to reality. So really that's where it started. I realized data speed wasn't that important. Impedance, maybe not that important. I mean, it's plus or minus 15% anyway. It came back to going straight back to basics. What's going to work? So I had a lot of wires on hand from the old days. So I pulled everything out and started, mixing and matching, working out what will work. And the first thing to do is to look at your data lines. And really you've got stranded wire, you've got solid core wire, you've got different metallurgical things, silver plated copper, all that sort of thing. So you've got to realize that that's a process that's going to take a lot of time, and it's totally subjective. There's no objective measurement you can do. You've got to build cables, you've got to listen to cables. And little by little, I built up a recipe of what was required in the cable.
That's really interesting what you're saying there. And it's going to lead us, I think, down a couple of different paths here, which will be really fascinating, I hope. Fascinating for me at least, and hopefully others enjoy it too. I think step one for me, I wanted to touch on quickly. You mentioned two things in there. There was the skin effect and the dielectric constant. Now, skin effect, I think I understand, which is the idea that the electrons in the cable actually move along the very outer edges or the skin of the wires, is my understanding. Is that correct in very layman's terms for skin effect?
Well, almost. I mean, skin effect, different frequencies travel at different depths within the wire. So you've got high frequencies on the outside, and as you get lower frequencies, they move into the interior of the wire. So there's a particular diameter that works extremely well for analog cables, but a different diameter that works particularly well with USB cables.
Interesting, because of the different frequency transfer, like the frequency rate.
Yeah, well, USB, very high frequencies. So you've got to look at that. But I mean, objectively, very hard to measure that. But subjectively, it's all subjective. You've just got to do a minor change and then listen to it. And the dielectric constant is, you've got to insulate the wire somehow. And everybody's heard of Teflon coated wire. Teflon is a very good dielectric constant. So as the electrons or the sound flows through the wire, the dielectric insulation will absorb a bit of that and then return it to the wire in a delayed form. So you get, it impacts on the sound. If you just had normal PVC, which is a shocking dielectric, then you get major impacts on the sound.
Okay.
But the best dielectric of all is air. So we use Teflon tubes that don't touch the wire at all. So it's sitting in an air dielectric. So look, that's an important thing. You just get rid of all the problems associated with normal insulation. You know, that's a big factor. Look, metallurgy, it took me quite a while to work out the metallurgy because stranded wires have a lot of problems and they don't work particularly well with USB. Some people may get them to work, that's great, but they haven't worked that well with me. I go down the solid core path, and from there you've got copper, you've got silver plated copper. So, you know, trial and error and all these things, silver is where it's at. But with silver, it's a bit like grabbing a tiger by the tail. You've got to, you know, it's high conductivity and higher than copper. So you've got a lot to play with there, and it can be a little bit difficult. So we use a very nice silver made in Australia, and then we anneal it. Now, annealing is a heating process. If you went down to your annealing engineering shop, they'd throw a spool of wire into an oven and bake it. And that's their term of annealing. But it doesn't work that well. We use a strand annealing system that heats it as it's being drawn. And some people call it relaxing the molecules. I'm not quite sure if that's the case, but it just sounds a lot better. And so it's an annealing process. It's directional. So all those things came into play with the design of the cable itself. But the interesting thing is, a USB cable is actually very similar to a balanced analog cable. Everybody knows about balanced analog cables used in recording studios and high-end systems for reducing noise. And they do that because they have two data wires, a data positive and a data negative. And you've got, in layman's terms, you've got mirror image signals traveling down each one. And then at the receiving end, they're summed. And if there's any noise on those data lines, they get cancelled out at the receiving end. So USB is identical. It runs two differential signal wires, data wires, and noise is taken care of at the other end. And I'll come back to that, because once you understand that, you say, well, hang on, if that's taking away most of the noise, do we need shielding around our wires? And, you know, when you start playing around with shielding, it does a lot of bad things. I find sonically, it can shut down the sound and so on. So, you know, from my point of view, I started by shielding other parts, the ground wires and the power wire, to prevent any transmission from those wires into the data lines. And I found that to be a much better way of doing things, rather than trying to shield the heck out of your data wires. Now, you know, some designers may have had success with that, but to search for the sound that I'm interested in, I couldn't make that work. So I've done it a different way.
Yeah, that's interesting. That makes a lot of sense. And I don't want to go too far down the rabbit hole now, so I'm going to save this till the end and talk to you about a video. I may have sent it to you in a link. I don't know if you've seen it. There was a fascinating video on Veritasium recently looking at how signal actually travels through a wire, whether it's AC voltage or...
I got that.
Yeah, and it kind of blew my mind when I thought about it from an audio point of view. But let's park that one. We'll come back to it at the end. One little thing I wanted to clarify quickly, because I know that there is some tension in this topic around what's subjective, what's objective, what's science, what is snake oil to some people. The ideas of skin effects and dielectric constant, I should say, those are actually proven scientific phenomena, aren't they? That's not just some...
Correct.
Yeah, cool. I just wanted to clarify that for anyone that was listening, thinking that was just marketing jargon.
It's cable making 101. So everybody understands that and knows that.
And that's true whether you're buying a power cable, an audio cable, Ethernet cable, they all have to consider those things because they're scientific phenomena, yeah?
Correct. That's right.
Did you have any any engineering, electrical background coming into this, or have you kind of learned as you've gone and built your knowledge through experimentation, talking to people, etc.?
No, I'm not a digital engineer or an electrical engineer, but I've got very good ears. So if you've got good ears and you've been listening to music and been an audiophile for a long time, you get the hang of it and what's required. And I bone up on the electrical side of things for sure. And I play around with electronics. I'm, big on power supplies and making power supplies and, building DACs and things like that. So I come from a DIY background. And as I said, I mean, I made this USB cable primarily for myself because I couldn't get digital audio to sound that good. Once I cracked the code, I started to enjoy digital audio. People out there who can't hear the difference between USB cables, I have no problem with that at all. I've got a friend who can't tell the difference between, a $5 bottle of wine and a $30 bottle of wine. And I think that's fantastic for him. He's saving a lot of money.
Yeah, that's right.
It doesn't matter. It's the people that do hear the difference and they can understand what a good cable will bring to the system. That's important. And it's not snake oil because you can hear it. It's so obvious in a good quality system. And I've got friends all over the place with great systems. And, we often go over there and listen, A/B test things. And the difference, everybody can hear the difference. It's not rocket science, really. It's coming down to the fact that the greatest measuring tool ever invented were ears. And really, you can hear the minutest change in depth, in image, in whatever. It's just an amazing thing. So it's a subjective thing, and that's where I come to it from. And with the making of the USB cable, it was all subjective. I just did trial and error all along the way, bearing in mind those things that I've mentioned, the scientific side of things that you need to keep in mind.
I think one of the really interesting things that you've said there, and I think it's often underestimated by those that are heavy on measurement focus, is that there is still a lot that we don't understand about how the ears work. There are things going on. You may or may not be interested in this stuff and therefore may not have seen it, but there's some studies going on at the moment where they're looking to understand the fact that there are parts of the brain that light up from an auditory point of view when we're listening to music with frequency content above the audible range. So there might be 30 kilohertz plus that we know that we cannot consciously perceive, and yet the brain lights up when that's there. And when they play back the same music with that content removed, those parts of the brain don't light up. So the reason I say that here is to sort of highlight the fact that there is still so much we don't understand about the ears. And as you just said, and I think it's a really good point, our ears are much more sensitive than we give them credit for. They definitely have limitations that, an AP555 or whatever it's called, I can't remember the name off the top of my head, measurement device will absolutely measure things that our ears can't. 0.03% of total harmonic distortion we would never consciously perceive. But in my experience, there's other things that our ears perceive that those devices don't measure because we don't even understand what they're meant to be measuring yet. There's no variable that you can say, this is what we're looking for, because we don't know what that is. So I think that's a really good point you made about the ability of our ears to actually really measure things and understand things that test equipment can't, because we don't even know what it is to test for.
But, and as I said, I mean, different designers have their own ideas of how everything should sound, how a cable should sound. And it's up to the consumer, the audiophile, to say, well, I like that interpretation of sound, or I like this interpretation of sound. So it's the whole business of audio is a subjective thing.
So subjective. Yeah, that's very true.
And that's why different people have different systems. If everybody liked the same thing, everybody would have the same setup in their house.
Absolutely.
So everybody's got different ideas, and you're always tweaking, improving, playing around with this, that, and the other. So that's what being an audiophile is all about. It's the hobby. And if you say, cables don't do anything. They don't make any changes at all. Well, that's fine. But for those who do, it's part of the hobby, part of the process. It's those couple of percent improvement here, a few percent improvement here, and suddenly, you've got a serious improvement in the sound.
And I think that that's ultimately been the takeaway for me, particularly as I've gone through this journey with USB cables, is that I did a review recently of the Supra Excalibur USB, which is a much lower price compared to something like the Curious Evolved. But what was fascinating to me was I found myself loving it on one particular DAC. And then I moved it to a different DAC and was like, well, okay, it's good, but it's not as good as something else. And so the ideas of system synergy and both from one device to the next, connecting them up, but then also personal preference comes into play, how that particular cable sounds on that particular DAC I might like, but somebody else might not. They might go, no, I prefer this particular cable on that particular DAC. So I think that's a really good point. It's such a subjective thing. And I think we get trapped because it's digital, we get trapped thinking that it's this absolute unchangeable constant when in actual fact it's not. And that probably leads me to a question I wanted to ask you and see if you have any insight. Maybe you don't on this one. One of the arguments that gets put forward, and it's very understandable, and it's something I've grappled with, the idea that even if it is, or even knowing that it is an analog waveform traveling through a cable representing data, the idea in theory is that as long as the cable is carrying a certain voltage at a certain point in time, and there's a little bit of leeway in where that sample might actually fall, but the theory is that as long as the cable is representing the increase and decrease in voltage somewhat appropriately, that the DAC receiving the information is going to take that input, it's going to know where the sampling of that particular moment should fall in time, because it's often doing its own reclocking and fixing jitter issues and the like. And therefore the end result should be the same exact piece of data, regardless of the cable that's come down, regardless of the DAC it's going to as well. And that's a whole nother topic. Is there anything that you can add to that conversation in terms of why a particular cable or two particular cables that are carrying the exact same data, it's within the specifications of USB cable transfers, why those two cables could possibly alter the end result? Do you have any insight you can give us? Because I don't.
As I say, it's this recipe for a cable design. To give you an idea, the ground plays an enormous part in the whole process. And its relationship with the data lines, very important, because as I say, there's capacitance involved here. And normal electrical cable matters such as I've mentioned, inductance, capacitance, resistance, all come into play. I'm sure they do, because as I've tried various experiments, I can see that that's the story. And in the early days of prototyping the Curious, I had a couple of little niggling issues in the upper mid-range, and it came down to the ground wire and the way I was arranging the ground wire. So that has a big impact on the sound. The other big impact on the sound are the connectors, and this is what a lot of people don't realize. We'll throw wire together, we'll go down to the local, electronics store and get a couple of USB connectors. They all sound different. And unless you line up 10 of them and are prepared to listen to each one, you won't realize that they all sound different. And so with the Evolve cable, we do a modification of that USB connector that makes a nice impact on the sound. So these are the things, look, who knows? I don't know. If you ask that same question to a digital engineer, he would come up with all sorts of stuff about jitter and clocks and all sorts of things. But in reality, you've got to make a cable that sounds good and does the job. Again, it's a subjective thing. I think the whole thing must be subjective, because as I say, I've listened to cables designed by digital engineers based on objective measurements, this cable, according to them, can't impact on the signal whatsoever. Yet you listen to it and it doesn't sound that great. So, you know, it's one of those things, maybe in 10 years, 20 years time, we'll get a better understanding of what's going on. But I hark back to that round table of all these different cable designers. They all had different interpretations, different ideas. And so it just comes back to, this is audio, you know.
Yep.
When you get into AC cables, that's a new horizon. That's, you know, a whole new can of worms. How can, you know, a meter of cable at the end of hundreds of meters of wire impact the sound? Yet it does. So, you know, again, an objective guy will say, well, it can't impact the sound, yet you can hear the difference. So I'm a subjective guy, and that's, you take it or leave it. You know, that's the way it goes.
Yep. No, and I'm completely aligned with that. I was hoping you might say, well, we've discovered this, but no, I'm still searching for that answer. But yeah, I think to add to what you just said, I think I talked about this in the Excalibur cable review, the AudioQuest Diamond cable, which is their top of the line. It's a very expensive cable. It's therefore got all the technologies that they think make the cable the most pure in terms of data transmission. And yet I prefer the one down from it that's technically maybe not quite as spectacular. And then I prefer the Curious Evolved above both of those, again, in most situations. Having said that, the Diamond is actually my preferred cable using with the Yggdrasil DAC. So again, it's synergies and subjectivity and all that stuff. So yeah, I think that's a really interesting point, that there is often a difference between the objective perfection and the subjective listening experience. So
yes, that's
hard to actually quantify that still.
And synergy, as you say, it's all to do with synergy. And so that's another, you know, thing you've got to keep in mind.
Just to complicate things even more for us all.
Sure, yeah.
One of the things I thought might be interesting to get your perspective on, as someone who's gone through the journey of building your own cable, experimenting, playing around, if you were choosing a cable today, and let's assume for a moment you couldn't afford to buy a Curious cable, because that's obviously what you would choose based on the fact that you designed it to be what you like to listen to.
Sure.
What would you be looking for in a cable design if you were shopping on the market? Are there certain things that people can say, it should have this or it should have that, that should result in a better sound? Or is that also going down a path of maybe missing out on what matters, which is the subjective experience? And obviously I ask this knowing that it's very hard for people sometimes to hear the USB cables before they buy. Is there anything to look for, or is it really have to be trial and error?
Well, I think there are some things to look for. One is solid core is better than stranded conductors. So the first thing to do is to look for a company that has a cable based on solid core. Oftentimes you can go to the major manufacturers, look at their top of the range, what they've done there, and then trickle it down to their bottom of the range. And have they maintained similar design parameters? So that's the thing. Oftentimes, they just do a little bit more silver coating over the wire. So sometimes there's 3 or 4 cables in a range with just a little bit more silver coating on each one that leads you up the path. So, you know, you can go down the range, find, okay, that's got, you know, enough silver coating for my requirements. It's solid core. And you know, I guess you've got to read reviews on forums, or if you've got a lot of audiophiles have audiophile friends, you know, get some friends over, borrow cables, listen to that sort of cable and see what you think. But first of all, you've got to work out, am I a wall of sound guy that likes a lot of information presented up front, or am I a dimensional guy who likes to get involved with the holographic type of performance? And once you settle on that, you'll get a bit of a handle on it. But yeah, they're the things I would look for, number one.
I've never particularly enjoyed, from an analog perspective, I've never particularly enjoyed silver-plated cables. Yeah. I generally prefer pure copper. Most of the time it's pure copper, particularly in headphone cables. Sometimes it's pure silver, but very rarely do I like silver-plated. There are exceptions, but it's unusual. In digital and recognizing the skin effect that we spoke about before, knowing that I know some of the manufacturers out there talk about the idea that by making a thick enough silver plating, you're essentially getting all of the signal being transferred in the silver rather than the copper section of the wire. Do you have a view, like is a solid silver wire, so solid core and all silver, is that the ideal, or is it actually a copper silver combo? Does plating not matter overall in the scheme of things? What's the take on that?
No, I agree with you 100%. Solid core copper or solid core silver is my preference.
Okay.
As soon as you start silver coating copper, you've got a discontinuous situation going on because you've got, it's much higher conductivity, the silver. And as soon as the frequencies go down into the wire and get to copper, there's a discontinuous nature with the slowing of the sound. It doesn't work for me. But all right, how thick? I don't know. I haven't tested all the wires, the thickness of the coat. It may help. But in general, I agree with you. Solid core copper, solid core silver, ideal.
Okay, and that's true for digital as well as analog in your experience?
Yeah, for sure, absolutely. Different applications. I mean, I've mentioned stranded wire being not my preference for analog or for digital, but stranded wire for AC cables, for main cables, very good. And
interesting.
And this is, I mean, we're dealing with frequencies, 50 hertz here in Australia, 50 to 60 hertz overseas. So you've got a very low frequency going through here. And as soon as you break that up, if you had a lit style cable, and I've been playing around with AC cables, if you have a lit style cable with, let's say, 6 strands of wire, that doesn't work for me particularly well. But when you have, a 12 gauge, very high purity copper stranded wire with Teflon insulation, now you're talking. That starts really getting good.
Interesting.
And then the trick to that then is separating the active from the neutral. So it's the separation. If you can't have them too close together, but you can't have them too far apart, you've got to experiment and again listen to what you're doing by separating them. And once you come up with that and you crack the code, you've got a pretty nice AC cable, but it's a stranded wire. So you've got different applications for different wires, and that's what it all comes down to. So
that's fascinating. So does that mean there's a curious AC cable coming soon?
No, because the problem with AC cable is the rules and regulations around the world, and very difficult to meet and very costly. And so realistically, I've got a cable that I've designed for myself, and some of my friends have got it, but realistically, it's not a marketable thing. It's too difficult in too many jurisdictions, So it's one of those things.
So let's go down the rabbit hole, because I think you actually just provided a really nice segue there, and we might end up getting nowhere with this, but let's see what happens. So I'm going to try and summarize really quickly for those that haven't seen it, and I'll put a link in the description for those that want to watch the full video. There's this video on Veritasium where he's gone through and explained the way signal is actually transmitted in wires, and the key takeaway from it is it's not even transmitted through the wire, it's actually transmitted through the magnetic field and the electrical field around the wire. And there's evidence of it. It's scientifically provable. It's not someone's theory. This guy does all of his stuff based on very solid research and scientific theory. Where that took me thinking, he was talking purely about power running through power cables and things like that. Although he did talk about underground telegraph wires and how they were affected by the ocean when they first ran those, because the ocean messed with those fields. Where that led me to thinking, though, and it's very interesting, you've talked about the data lines in the USB cables performing better with less shielding, was it got me thinking that all these manufacturers are looking for hyper insulation of their cables, which in theory would be restricting the amount of electromagnetic and electrical field that they're generating around the wire. And therefore, I wondered if that's affecting the quality of sound. And now here you come along talking about, which I had no idea before you said it today, the fact that you focused more on insulating things like the ground, the power lead through the USB, and not so much the data leads. Have you got any thoughts on how that whole phenomena might be impacting? And let's stick to USB for now, and then, you know, analog cables is a whole nother story. But any thoughts on what might be going on in that process? And actually, sorry, let me say one more thing. The upshot of all of it, and the thing that kind of blew my mind a bit, was the electrons aren't moving through a wire. They're basically vibrating a little bit within the place that they're in, very, very slowly progressing. But it's the field created from that movement, the field's created around the wire, that's actually sending the signal through. So with that said, Rob, any thoughts on what's going on in relation to that in USB cables?
Well, that's a crazy video and everybody should watch it. What I found interesting was the comments. There's hundreds and hundreds of comments from physicists, from electrical engineers. But the guy's right. It does travel as an electromagnetic field on the outside of the wire. And sure, I agree 100%. Any shielding, subjectively, what shielding of wires has done for me always is shut the sound down. Suddenly a big open sound stage gets shut down. So objectively, it could be this theory of the magnetic fields traveling along. And I mentioned to you previously with our ground wire is very interesting. And the way I use the ground wire in the design, I'm hoping will be a transporter of that electromagnetic field. So objectively, who knows? But subjectively, I think that that's one of the reasons it works so well. So yeah, I think that video is extremely interesting. And everybody thinks that electrons, you know, it's a bit like water through a pipe. Everybody thinks that's the way electrons go through to create sound. But as they say, the movement is very slow. They just bump each other and don't really travel anywhere, but they create that field that pushes it through. And that's, you know, almost a revolution. It's been, you know, mentioned many times before, but this guy sort of nails it. And it's one of those videos you probably need to watch a couple of times to get your head around it. But it's the comments that are very interesting.
Yeah, agree. And it was really interesting to see some people come on who are, as you said, physicists and electrical engineers, people that understand what they're talking about, saying, thank you for putting this out there. We've always been too scared to talk about it, sort of thing, because it's almost like the USB cable conversation where it breaks people's expectations of how things actually work. And I must say, I still haven't finished grappling with what it means for audio transmission through wires, because it boggles the mind when we're so used to the idea that, you know, even the headphones I'm wearing today, I've always had the assumption in my head that there's a series of electrons that's run out of my amplifier, up to the headphone, through the voice coil, back out the wire, and that's what's made the driver move. Whereas what's this saying is, no, there's an electromagnetic field running around this cable here that somehow is then able to influence what's going on inside the headphone. It's just, yeah, blows my mind. So
yes,
I've got a lot of grappling to do.
A difficult concept to grapple with.
It really is. It really is. So I think, Rob, we've covered some nice ground. I think we've hopefully given people some insight into why USB cables are probably a lot more art than they are science at this point. Not to say there's not a lot of science that goes into them, but that there's so much more to it than what we maybe think. Is there anything that we haven't covered that you would like to add to the conversation around USB cables, knowing that there'll be some people watching this video who probably aren't watching this video anymore that flat out disagree with us. There'll be some people who are watching this with an open mind who haven't yet really experienced differences in USB cables, and those that are absolutely interested in exploring USB cables and finding the right one for them. Is there anything else you'd like to add to the conversation around USB that we haven't covered yet?
Yeah, look, I think for those who don't know the difference or can't believe there's a difference, get a bunch of guys together or girls together with, you know, different USB cables and have a listen. Get some audiophile USB cables, just have a listen, keep an open mind and hear what you know, see what you think. Now, when you're listening, The trick to really listening carefully is making notes. You've got to make notes. People that just sit there and listen say, oh, I couldn't hear the difference. The brain requires, you've got to put down all these ideas on paper. It doesn't have to be a huge thing. You just mention, oh, that bass sounds this way, mid-range sounds this way, soundstage sound. You've got a scribble of notes. And then when you listen to cable B and you're writing a scribble of notes, then you can compare those notes. Hey, there was a difference. I didn't notice that until I had actually transcribed the difference on paper. I've got fool's cap books lined up everywhere because back in the old days, bullet plugs and, designing different connectors and so on, you've really got to make a lot of notes to work out what this is doing. And, the differences between solders. I used to have a big conversation with a guy in the States, and we'd compare notes about solders making such a difference. So in audio, everything makes a difference. But as you're listening, particularly if you're seriously evaluating anything in the system, you've got to make notes.
I think that's a great point, Rob. And to add to that, one of the things I've noticed in chatting, particularly to the channel patrons, we've got a lot of chat going back and forth on the Discord channel. One of the things that I find comes up a lot is what people are actually listening for when they listen to music. And none of what I'm about to say is meant to be criticism, because it's all a learning journey when you first get into this hobby. Most people will focus on bass, mid-range, and treble.
Yeah.
And
sure.
The key for me, and this is particularly probably for me with DACs, when you go to DACs like, say, a chord DAC or a shit multi-bit DAC, as opposed to one of the AKM or Sabre-based chip DACs, the thing that changes the most is not the tonality, it's not the bass, the middle, the treble in most cases, it's the depth.
Yeah.
It's the soundstage size,
Space.
The focus of the image, the space, exactly. And so what I wanted to add for anyone that's wanting to follow your advice, which I think is fantastic, is to actually, for every single thing you listen to, think about it in terms of, as you said, bass, mid, treble, soundstage. And the one other that I tend to add for myself is the sense of attack, the sense of crispness and clarity in the leading edge of notes. I think that that's a really good point you've made, is when you start making those notes, your brain is drawn to each of those aspects as you listen, and you start to hear the differences, which might be just space in the soundstage and nothing else, or it might be just the attack on the note, or maybe the bass is a bit fuller. It can just be one of those things, but I think it's a really good point to focus the listening like that. And you saying that reminded me of the thing I've been grappling with in the back of my mind that I wanted to ask you before. One of the common things that comes up with USB cables when I talk about them is this idea that you have to do blind listening in order to get your expectation bias and whatnot out of the way. Now, I don't personally agree with that, because I think there are multiple things we can do to overcome bias if we're aware of it. I've also found that I've had experiences that go completely against my expectations, like the Audio Quest example I said before. I much prefer the Coffee, which is cheaper than the Diamond. The expectation should be that the higher price cable is better, but that's not what plays out. So I just was interested in your take when you've been doing your listening tests. Are you a fan of blind testing? Do you use both? Do you use extended listening, A/B switching? Any advice for people doing listening tests?
I'm not a fan of blind testing at all. I think it's counterproductive, really. When I get serious about listening, so I put cable A in, and I usually play only 2 tracks. And I've got a couple of, nice reference tracks that give me a lot of information. So you've got to find tracks that give you the information that you're looking for. And most of those are simple tracks. They're not busy tracks, they're simple tracks. So cable A, 2 tracks, and I've made notes, copious notes, just whatever comes to mind about how that sound is sounding. And then in goes cable B, and back to your notes on cable B. For me, it's a foolproof way, because the notes don't lie. You're evaluating, you're transcribing your evaluation immediately, and that one. But you've got to make notes. A lot of people don't make notes, and you can't evaluate successfully without that sort of notation. And you can give them scores sometimes. after I make those notes, I'll say, well, that's 8.5 out of 10. And you're listening to the next one, and it could be 8.75 out of 10. And I often, when I talk about soundstage, in shorthand, I'll write 2.5D. So it's not quite 3D. It doesn't bring the holographic nature. Or if it's a real wall of sound, that's 2D. So it's immediate soundstage. What does that soundstage look like? What does it sound like? My biggest advice to anybody who's evaluating any component, be it cables, electronics, whatever, it's note-taking.
Something you said, and there's a really great point for this discussion in particular, which is the moment you're looking at each aspect of the cable, it's no longer just cable A is better than cable B, and that's where our bias would come in, that, the more expensive cable's better, or the one that I like the look and feel of is better and therefore is going to sound better. Doing what you just described with the note-taking, it takes the better and worse out of it, and it becomes, it sounds like this, and this sounds like this. And then after the fact, you go, well, which one did I actually like better? But by that stage, the bias has been dealt with because you're just looking at the subjective notes on each individual aspect of the sound. So that's a really interesting point. I just want to jump in briefly here because Rob's made a really good point here. The moment you start looking for faults in something you're listening to, and also when you're listening to something in terms of individual characteristics of sound, rather than straight up best or worst, what you're actually doing is starting to overcome your own unconscious bias and the assumptions that you might have made coming into a listening test. I know some people believe it's necessary to do blind listening tests, but they have their own drawbacks, as I've talked about previously. And so I wanted to take a quick moment just to draw out what it is that's going on here. When we have an assumption going on in our mind, it's generally a very simple categorization of what we're listening to, looking at, hearing, talking to, etc. It can be anywhere at all. But what the assumption is doing is our brain has made its mind up about a certain thing and it's categorized it. It said this cable is going to be good or this cable is going to be bad. Or this album's going to be good or this album's going to be bad, whatever it is. And so the key thing in overcoming any kind of bias, whether it's an expectation bias of a cable, whether it's the belief that something's different or not different, it's all about actually testing those assumptions. And the moment you start thinking about things in a more complex way, in terms of what do I like about it, what don't I like about it, how does the bass sound, the treble sound, the mid-range sound, the soundstage sound, all of those things are going to take you into a way of thinking that goes beyond the limits of what unconscious bias is capable of. And so I just wanted to call it out because I think it's a really great point that Rob's made here. If you're doing listening tests, and particularly if you're listening to devices that are very similar or where you have very strong biases, make sure you do it in the way that Rob's talking about. Take notes, look for faults as well as benefits, and think about it in those terms of bass, mid-range, treble, soundstage, transient attack, all of those things we've spoken about. It's really going to help overcome unconscious bias, and it's actually more valuable in my experience than a blind listening test. Unless, of course, you're doing all those same things blind, in which case you're going to get the same results anyway. So I'll jump back out of the interview now and hand us back over to Rob Woodland.
Yeah, you're almost converting subjective, what you're listening to objective on your notes. So you're telling it like it is, and you're not fibbing. You're not massaging, you're just explaining what it is. And you've also got to listen for faults. A lot of people don't listen for faults. They pick up on, wow, that detail is incredible. Yes, but what about the image of that female vocal? Was that smooth and was it dimensional? You're getting all this detail, but suddenly that vocal, it's done something to the vocal. So you've got to be able to listen to faults. And look, it's a learned process. I've been doing it for so long. I've got my notebook with me wherever I'm, all the time listening to stuff. So consequently, it's a learned process. But once you get the hang of it, it's fantastic.
Yep. I think it's a great point, and probably a really nice place for us to wrap this up, because I think that advice is just gold, Rob. That's really fantastic. Thank you.
Well, thank you, Lachlan. And it's been great to talk to you today. The hour's sort of gone by very quickly.
It does that, doesn't it? Yeah. So no, I really appreciate your input, Rob. It's fantastic to hear from someone who's gone through the process. And I think in some ways it's better that it's coming from someone who's been an enthusiast and explored it for yourself, like most of us are, not to the degree you have of building our own cables, but trying to find what's right for us and determine that. So it's really valuable you sharing that experience and that journey with us. So thank you very much for your time. And for those who are interested in Rob's work, I'll also mention that I've now just received from Rob the Curious XLR cables. And I was saying to Rob before we hit the record button how excited I'm going to be to share these, because they sound fantastic. So I look forward to sharing that one soon. And Rob, thanks again for your production of cables to make our music experience better, and also sharing your time with us on the interview.
Yeah, you're more than welcome, Lachlan. Thank you.
Fantastic. Thanks, Rob. I hope you've enjoyed watching and listening to this interview as much as I enjoyed creating it with Rob. It was fantastic hearing his journey through USB cables, hearing what does and doesn't matter. Obviously, he couldn't give away his secret sauce from the Curious Evolved, but I think it gave us a really interesting sense of why some cables sound different to others in the sense of the different materials, insulation, etc. Don't forget to go and watch the Veritasium video. I've linked it down below. It's a bit of a mind-blowing concept when you start thinking about it in terms of audio. So do take a look, come back over here, tell me your thoughts on what it means for audio, and I'll look forward to hearing some different perspectives and different opinions. As always, if you've enjoyed this video, I'd love it if you'd subscribe and like. It really helps me to keep making videos like this. Being able to get industry insiders to give up their time and share their knowledge is much easier as the channel grows. So please do consider subscribing. It does really help out. For now though, let me leave it to the music. So happy listening, and I'll see you here next time on Passion for Sound.